Hello Year 12, welcome to our next video here. We are looking today at integrating the reciprocal function, that is 1 over x or x to the negative 1. Previously that's caused us problems, but we can integrate it now using logarithms. Right, we've already seen that when I differentiate log of x, I get 1 over x, so if I integrate 1 over x, I get, unsurprisingly, log of x. So here we go, first case here, pretty straightforward. We get the log of x from 1 to 2, and the log, that gives me, the log of 2 minus the log of 1, and the log of 1 is equal to 0, because e to the power of 0 equals 1. That's what it means. So simply we get the log of 2, that definite integral there. There are some other forms here, right, that will appear on your formula sheet, but you also need to be a bit familiar with. Righto, some other ways of doing this. Now I've just noticed here I've got a slight typo. That shouldn't be e2, and that's e squared there. If you could amend your notes to reflect that. Right, we've got a couple more definite integrals. We're going to refer back to these a little bit as we go. But this here, we're going to write this as, I'm just going to rewrite that first as 5, because I can take that constant out, outside of the integral, from e to e squared of 1 over x dx. Right, equals 5 outside of the log of x from e to e squared equals 5 outside. Now the log, let's say the log of e squared. Now the log of e, right, e to the power of what equals e? E to the power of 1. So that's minus 1. I'm just going to simplify that a little bit first. And this thing here, right, remember I can pull that power out the front, so it would be 2 times the log of e, that's 2 times 1. So, I get 5 times 2 minus 1, which is 1. I get 5 times 1 is simply 5. That works out very neatly. Now, over here, I'm going to use this sort of thing here, this second of our standard forms. And I'm going to say that this is, I sort of don't have to do as much work as I did there, I guess. This is simply the log of 2x plus 1. Oh, no, it's not. It is 1/2. It's 1/2 times the log of 2x plus 1. Right. 1/2 times the log of 2x plus 1 from 0 to 1. So I put 1 in here and I get 1/2 times the log of 3, right? So I get 1/2 times the log of 3, and then I put a 0 in here and I get the log of 1, right? 2 zeros plus 1 is 1. The log of 1, remember, is 0, so I don't need to worry about the thing I'm going to subtract. That's my answer there, 1/2 log 3. Okay. Keeping it simple. Now, these ones here, we need to be a little bit more careful. I have a slightly more complicated function down here in the denominator, down the bottom. I've got an x squared there. Now the top is like the differential of this. It's like this. If I differentiate 9 minus x squared, I get something that's not a million miles from x, but it's not x. So I need to rewrite this integral in the first place so that the top is very clearly the differential of the bottom. Okay. Now, if I differentiate 9 minus x squared, I get minus 2x. Right, I get negative 2x. I've just got x at the top. So, I'm going to start by, I'm going to say that this is negative 1/2 times the integral from 0 to 2 of negative 2x over 9 minus x squared dx, right? If I expand that out, and remember I can pull the constant out there if I like, I multiply this thing here by negative 1/2, that makes that a positive, and the 2's cancel, and I get x over, right, I get my original thing here. So these two things are equivalent. Now I have the differential, right? If I differentiate the bottom, I get what's up the top there, so I can jump now to negative 1/2 outside of the log of 9 minus x squared from 0 to 2. Now I do my substitution here. if I put 2 in here, I get 9 minus 4, so that's 5, the log of 5, negative 1/2 outside of the log of 5. And then I put a 0 in here, I get the log of 9 minus 0. So I get the log of 9, which is the log of 3 squared, which is 2 times the log of 3. All right. Pause and rewind that if it doesn't make a lot of sense. Remember, so this is a 0. I get the log of 9. 9 is 3 squared, so it's the log of 3 squared. I pull that power out the front. So the 2, that exponent comes out here. The log of 3 squared is the same as 2 times the log of 3. So that's how we've written that. Now I'm just going to expand my brackets there. Right, because the negative half and the negative 2 log 3 works out nicely. I get the log of 3, I'm just going to rewrite it to make the positive first. Log of 3 minus half the log of 5. Righto. That's a terrible N. Rightio. Wonderful. Now we're just about done for this video. We need to do one of these backwards things, you know, where we say, oh, well, I don't... I'm given the differential. And I need to find the original function. There's not much to it. You integrate it, and then you substitute in something to find the value of that constant. Right, we've got another part here, you know, substitute 2 into that, and it's not going to be terribly complicated. So, the integral of 2 over 3 minus x is just a slight problem because of that negative there. Right, dx. I'm just going to rewrite that as negative. Because I want the top to be negative 1. So I'm going to have a negative 2 outside of the integral of negative 1 over 3 minus x dx. Right, can you see what we've done there? Just so that the top is the differential of the bottom. Right, negative 1. That negative 2, I can still expand it. I would come back to the positive 2. Right, so this means I get the negative 2 times the log of 3 minus x plus a constant, because this is an indefinite integral. Right, so that means that function x, that's what we've found now. Function x is this thing here, but I don't know the constant. I do know that it passes through the origin, so function of 0 equals negative 2 times the log of 3 plus a constant, and I know that's equal to 0, right, because it passes through the origin, right, 0. It's equal to 0. Function of 0 equals 0. Now I can solve this, and I get 2 times the log of 3 equals constant. My constant is 2 log 3. Therefore, my function is 2 log 3. Again, I'm sort of writing back to front, so we get a positive minus 2 log of 3 minus x. Right, so there's my function. That's great. That's part A done. Part B, it won't take forever. Part B, function of 2 equals 2 log 3 minus, now I'm going to have the log of 3 minus 2, the log of 1. The log of 1 is equal to 0, so I don't need to worry about subtracting anything. Function 2 is simply 2 log 3. All good? Hope you enjoyed it. See you in class.